Hi, hello, and welcome to this week's data topic with your host, Miss Avra. Today we'll be talking about frequency tables and box and whisker plots. And these are just ways that we can represent our data once we've done some data analysis. So these are two new ways of representing data. We talked a few classes ago about things like pie charts, bar graphs, tables. These are just two new visual representations of data that help us maybe see some different trends in data that we've gathered. So our first one are frequency tables. We saw these in some of the example problems from last class. But first we're going to talk about what does a frequency table show? Well, it represents the frequency, hence the name, of repeated data points. Okay, so if I have a collection of data, I think the last one was AP scores, or a collection like this, it is number of runs per inning. So there were 0 runs in 4 innings. There was 1 run in 3 innings. So instead of having to write out 4 zeros, like having to write the same data point over and over again, we can just say there were 4 innings that had 0 runs. There was 1 inning that had 3 runs. Okay, so this makes this a little more interesting when we're calculating things like mean, median, and mode. First thing that I'm going to list out is median, because I think it shows you what data is really contained in here. Okay, so if I'm calculating the median means I list all my values from least to greatest, cross them off until I find the middle. Okay, well in this one, number of runs, I had 0 runs in 4 innings. So I'm going to write 0 4 times. 1, 2, 3, 4, because it occurred 4 times. I had 1 run in 3 different innings, so I'm going to write 1, 2, 3 times. I had 2 runs in 1 inning, so I'm going to write 2 once. And I had 3 runs in 1 inning, so I'm going to write 3 once. This number here tells you how many times the data point actually occurs in the data set. This is just a neater way of organizing it than writing all the numbers out, but this is how we help find the median. So I'm going to cross them off till I get to 1 in the center, 1 on the left, 1 on the right. Crossing, 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 until I end up with 1 in the center, so my median is 1. Okay, next thing I'm going to look at is mode. Mode, remember, is the one that occurs the most often. Okay, so if I'm looking at that, mode in this case means which has the highest frequency. Okay, so I'm going to go down here. The one that has the highest frequency is 0. 0 is my highest frequency because I had 0 runs occur 4 different times. Okay, the last one we're going to calculate is mean, and I think this is the trickiest one, but if you really understand what mean means, then it's a little easier to calculate. So mean is the sum of data over the number of data points. Okay, the sum of data over the number of data points. Well, let's find the sum first. Okay, well, I said here this isn't just 0, it's 0 4 times. So I'm going to multiply these together to get my total data. So 0 times 4 is going to give me 0. 1 times 3 is going to give me 3. 2 times 1 is going to give me 2. And 3 times 1 is going to give me 3. Okay, that is the total number of runs that occurred. If I add these together, I get the sum of my data. This is the number of runs. Okay, the total number of runs that occurred. Okay, so I'm going to add these up. 3 plus 2 plus 3, 6, 7, 8 goes in the top of my fraction. Now, frequency, number of data points. Well, number of data points I'm going to get by adding all of my frequencies together, right? Just like I listed them out here. 4 plus 3 plus 1 plus 1, 4 plus 3, 7, 8, 9. So I have a total of 9 data points. So 8 divided by 9 is going to give me my mean. 8 divided by 9 is, we can round that to 0.89. Okay? So sum of data points, we calculate that by doing our number, okay, our data times its frequency, add those together to get the top. For frequency, or for dividing what we divide by number of data points, we add all our frequencies up because that's how many actual points of data there are. Okay, we're going to do one more together where I'm going to help you construct the table, and then you're going to calculate the mean, median, and mode, and then we'll look at box and whisker plots. Okay, this one says the scores on a math test are listed below. Create a frequency table, find the mean, median, mode, and range of the data set. Oh, I forgot to find the range up here. My bad. Range, again, is the largest number minus the smallest number. The largest number is 3. The smallest number is 0. 3 minus 0 is 3. Okay, so down here on our frequency table, I always start with the lowest number, so we're looking at scores will be one part of our table, and then frequency will be the other. Okay, so I'm going to start, it looks like 30 is the lowest one, so a score of 30, I see that 1, 2, 3, 4 times? 5 times. I see a score of 30 5 times. 40 is my next one. I see a score of 41, 2 times. Score of 50, 1, 2, 3 times. Score of 60, 1, 2, 3 times. A score of 70 twice. Score of 70 twice. A score of 80 once. A score of 90, 1, 2, 3 times. And a score of 100, 1, 2, 3, 4 times. And as you can see here, I missed one. Let's add in, I have 2 80s, not just one. These are really easy to like miss a data point on. That's why I crossed these out so I can see what I have left over at the end. All right, so let's calculate some stuff. We've made our frequency table. This represents that I have a score of 30 5 times, a score of 40 2 times, so on and so forth. Okay, so let's do what we did last time and calculate our mean, median, mode, and range. I'm going to start with median. We got lots of data points here, so I'm going to write them down here. Okay, I've got 5 30s, 1, 2, 3, 4, 5, 2 40s, 3 50s, 3 60s, 2 70s, 2 80s, 3 90s, and 4 100s. Oh, do I have room? Just barely. Okay, we're going to cross them off now. I'm going to zoom out a little so you can see the whole data set. Oh, okay. Cross one out here, one here. And my median is 60. Okay, so median is 60. I know it's annoying to have to write all of these out when you're like, I already put these in a table to show the frequencies, but that's really just to calculate your median. You wouldn't display your data this way. Okay, mode, next one. Mode is my one that has the highest frequency or occurs the most often. 30 is going to be my mode because I have 5 30s. Mean. Okay, I've got to have my sum over the total number of data points. Okay, so sum, I'm going to do 30 times 5. Remember, we multiply these together to get our sum of our data points. So 30 times 5. I've already done all these over here. So 30 times 5 should give me 150. 40 times 2 is 80. 50 times 3 should give me 150. Already did that up here. 60 times 3, 180. 70 times 2, 140. 80 times 2, 160. 90 times 3, 270. And 100 times 4, 400. Okay? So I'm going to add these up. I'm going to add all of these up. So 150 plus 80 plus 150 plus 180 plus 140 plus 160 plus 270 plus 400. And that's going to give me 1530. So that's the top. That's the sum of all my data points. Now for the how many data points I'm dividing by, I'm going to add up all my frequencies. Okay, so I have 5 plus 2 plus 3 plus 3 plus 2 plus 2 plus 3 plus 4. and that gives me 24. 1530 divided by 24 gives me a mean of 63.75. And then finally, my range is just my greatest value minus my least value. So 100 minus 70, my range is, 100 minus 30, that gives me a range of 70. Got a little ahead of myself there. Okay, so frequency tables help us represent data that has repeated data points, right? I don't want to have to write out all of these. If I'm someone reading or analyzing this data, I don't want to have to write out all of these. This is a much more condensed version of the data that still makes sense. Okay, next thing we're going to talk about is our box and whisker plots. We talked about last time, one of the issues with mean and median is that we cannot see the dispersion of the data, or we can't see kind of where the data lies. Do we have more data around our median? Do we have more data around the higher end or the lower end? Box and whisker plots help us see the dispersion or how spread out the data is. You'll also see this called a 5 statistical summary because there are 5 points you need to construct a box and whisker plot. So the dispersion, a box and whisker plot helps us see how spread out or how condensed data is. There are 5 main points that you need. You need the lowest value or the minimum, the highest value or the maximum, the median, and the lower quartile and upper quartile. Okay, the word quartile means in quarters. Okay, in quarters, I forgot the R there. So 1/4 of the data. Okay? So the biggest thing about box and whisker plots, how they show us dispersion, is that 25% of the data lies in each quartile. Okay, so 25% of my data is from the minimum to the lower quartile. So 25% of my data is here. 25% of my data is between the lower quartile and the median. Okay, 25% of my data is from the median to the upper quartile, and 25% of my data is from the upper quartile to the maximum. Okay, so I can see that my data is really concentrated between the lower quartile and the median. The smaller the quartile, the more concentrated the data. Smaller the quartile, the more concentrated the data. So a lot of my data is concentrated between the lower quartile and the median. Not very much of my data, or less of my data, is between, let me rephrase that. It's really concentrated, so I have a lot of values between this tick and this tick, right? I have fewer values between this tick and this tick, okay? 25% of my data lies here, 25% of my data is here, 25% of my data is here, and 25% of my data is here. The smaller the quartile, the more concentrated the data. Okay, so let's see an actual example of that. I'm going to change some of the things here. Q1 we call lower quartile, Q3 we call upper quartile, and Q2 we call median. Okay, so let's actually calculate and draw one of these out. It says 11 staff from a university visited a museum. The below given data shows their ages noted by a volunteer of the museum to issue tickets. Make a box and whisker plot. Okay, so first thing we want to find is the minimum and the maximum. In this data set, it looks like my minimum is 38 and my maximum is 53. Okay, I'm going to try to do these in all different colors so it makes a little more sense when I draw it down here. Next thing I'm going to try to find is the median. Remember, that means that I have to put my data in order. So in order, I want to make sure I don't mess this up. I've already done it once. In order, I've got 38, 42, 43, 46, 47, 48, 50, another 50, 51, 52, 53. Sorry, it went on to this. I should have scooted it farther to the left. Okay, median. Cross out your data till you find one in the middle. 38, 53, 52. 1, 2, 3, 4. 1, 2, 3, 4. Oh, 5. The point in the middle is 48. So my median is 48. Okay, the tricky part here is the lower and upper quartiles. Okay? Now, the way that we can think about this is median, essentially. What we said, we found the median from the minimum to the maximum. Okay, we found the median from the minimum to the maximum by lining all of our data points up. Well, the lower quartile is halfway between the minimum and the median. So we can just find the median of the median and the minimum. Now that sounds tricky, but essentially what you're going to do, this is for your lower quartile. You're just going to find the median of these values. So cross one here, cross one here, cross one here, cross one here. My lower quartile is 43 because it is halfway between my minimum and my median. I can do the same thing with my upper quartile, but I'm going to use my maximum value and my median. So all the values that are above my median to my maximum, I'm going to cross through, cross through, cross through, cross through. 51 is my upper quartile. Okay, so these are really the only two new calculations, and they're not necessarily new, they're just a different use of median. So you're going to take your lower values, find the median of that for your lower quartile, take your upper values, find the median of that for your upper quartile. Now remember that if we had two values in the middle and we had to calculate a median, okay, if we had two values in the middle and then had to calculate our median by dividing by 2, that median would be your median here. It would not be included in either of these when you recalculate the median down here. Okay, so if I had two numbers in the middle and then I had to divide by 2, that would be my median up here. Those two numbers that I used to calculate, the one on the left would be included in the lower set, the one on the right would be included in the upper set. Okay, now we have all of our material necessary to draw our box and whisker plot. So I'm going to draw my minimum and maximum first. My minimum is 38, so that's right about here. My maximum is 53, so that's right about here. Okay. Next thing I'm going to draw is my median, I think. Median is at 48. So my median is right here, about. My lower quartile is at 43. And my upper quartile is at 51. Okay, we are now going to connect all these together. I connect the lower and upper quartile together to form my box. I connect with just a straight line, the maximum and the minimum, to create my whiskers. Okay, and this is my representation of the data. Reminder that 25% of the data lies here, 25% lies here, 25% lies here, and 25% lies here. What that tells me, the upper quartile and this whisker are the shortest. So the data is concentrated above the median. Because the upper quartile and to the maximum are smaller. Because the upper quartile and upper whisker are smaller. Okay, and that is how you construct a box and whisker plot. Again, it just helps us see the dispersion of data, where my data is most concentrated around the median. All right, thanks for tuning in to this episode. At this point, you should flip your paper over and work on your practice problems on the back. We will have an exit ticket on this after you're done with your practice problems. That's it. Thanks for tuning in.